Welcome back, everybody. Today's topic investigates the relationship between money and prices in the long run. We're going to discuss a pretty simple set of mechanisms that will show that there is a positive relationship between the rate of money growth and the rate of price growth, also known as inflation. And the name of this theory that we are going to utilize to explore this idea is known as the quantity theory of money. Again, this explains the long-run relationship between money growth and prices, or monetary policy and prices. We're going to also add in another mechanism known as the Fisher effect. And the Fisher effect is going to help us connect the link between money growth and nominal interest rates. So the Fisher effect will suggest that there is a relationship between nominal interest rates and the inflation rate. And again, both of these together will explain the behavior of long-run price growth or inflation. We're going to start by just defining what money is. Money is defined as the stock of assets that can be readily used to make transactions. So we're talking really about the stock of transactable asset that allows you to engage in trade. In order for something to be considered money in the scope of this definition, it needs to satisfy three functions. First and foremost, it needs to be a viable medium of exchange, meaning people can use it to engage in transactions. The second important criteria is it needs to be able to store value. It needs to be a verifiable or valid store of value here, and this allows us to transfer our purchasing power through time. If something stores value, then you can use it to buy something now, you can use it to buy something later. Last but not least, we require that in order to consider something money, it needs to be a valid unit of account, meaning that it is sort of this common yardstick by which we are measuring all values against. Typically, what happens in cases where things are not considered money or where the function of money breaks down is related to usually bullet points 1 or 2 breaking down, and that kind of causes the rest of the pyramid to collapse here. Discuss two types of money. The two types of money that exist are commodity money. And commodity money is not that popular nowadays because it is tied to the quantity of an available good. So commodity money takes the form of a commodity that has intrinsic value, for example, gold coins. The classic example is cigarettes in prisoner of war camps, or you might have seen in prison movies, prisoners trading cigarettes, and that's used as money. So commodity money, there is some intrinsic value in the good that is being used as money. This is not to be confused with the U.S. monetary system, which utilizes a fiat currency system or fiat money. And this is money that essentially is only really worth the paper that it's printed on, aside from the fact that people place some intrinsic value on the ability to trade it. Okay, you pull out the dollars in your pocket, it's some combination of paper and linen. Other than that, it doesn't really have intrinsic value like a piece of gold, which can be melted down and make, weapons or jewelry. So the dollar itself, it has value because people believe it has value. Okay, if people decide that it doesn't have value, then that's a big problem for the U.S. fiat monetary system, and it's one that we haven't run into quite yet. But historically, if you look at societies that relied on fiat currency, unfortunately, the story isn't typically including a happy ending. A lot of people are asking about cryptocurrency these days. Where does that typically fall on the spectrum? Most economists would suggest that due to the price volatility of most cryptocurrencies, Bitcoin's a big one, due to the price volatility, it's not a great store of value. Truth be told, more and more and more vendors are accepting cryptocurrency over time. So it is being used as a medium of exchange at an increased frequency. But the price volatility, I think, is the big issue with cryptocurrency. Until that stabilizes, it doesn't function as a good store of value, and because of that, people will not want to engage as readily as using it in a medium of exchange. It is also arguably a type of fiat currency. There isn't really any fundamental asset that's backing your ownership of say, a Bitcoin, a piece of code up in the cloud. The amount of digital currency available, at least in certain cases, is constrained by computing power. So computing power kind of backs the rate at which the supply of these cryptocurrencies can be changing over time. But there isn't really a commodity backing it. So again, the reason why people buy cryptocurrencies is because they believe other people value that cryptocurrency, not because it has any intrinsic value. So that would also arguably fall on the fiat scale of the classifications of money here. Now, in terms of money supply and just a few basic definitions here, we're going to define here the money supply is the quantity of money that is available in the economy at a given time. This is a stock variable. And monetary policy is related to the control over the money supply. So when we talk about monetary policy, we're really discussing the control of the money supply, not to be confused with fiscal policy, which we talked about in a previous set of videos, which is any policy affecting the government budget like taxes or government spending. In the United States, the monetary policy is controlled by the central bank, and our central bank is the Federal Reserve. And this is a picture of the Fed building in Washington, D.C. And just a real quick rundown of the structure of the Fed. The Federal Reserve System consists of a board of governors. There are 7 members located in Washington and 12 regional federal banks located around the United States. And the FOMC, or the Federal Open Market Committee, includes a rotating set of boards of governors and regional Fed banks. The FOMC decides monetary policy, and the current chairman of the Federal Open Market Committee is Jerome Powell, appointed by President Trump in 2018. Just a real quick rundown of the Fed chairmanship. We had Janet Yellen was the predecessor to Jerome Powell. She was sort of the one that was dealing with the aftermath of the recovery of the housing crisis and the financial crisis in the Great Recession. Bernanke was sort of handed the keys right as that was happening. And Greenspan, he was in charge prior to this. He's kind of famous, or infamous rather, for his idea of irrational exuberance, but he is criticized for underestimating the degree to which markets would really regulate themselves. And Paul Volcker, and the list goes on, but these are really the 4 most recent ones that you need to know here. But Volcker, he was brought in to control inflation. Inflation was up around 13 to 15%, and he was brought in to control inflation downwards, and doing so required a trade-off, and that trade-off was there was an increase in unemployment, which wasn't popular at the time. But looking back, he is revered for his ability to control inflation downward from its high levels in the late 70s, early 80s. Money supply measures. This is the next topic I would like to get into. So I pulled a couple numbers just from June of 2018 here. The first thing we could think about in terms of trying to measure the amount of money in circulation is we could look just at the amount of currency. Okay. So as of June 2018, there's 1,580 billions of dollars in currency in circulation. So that's about $1.6 trillion of currency in circulation. This is not the only transactable asset, though, right? It's not just physical dollars that you transact. You also probably use electronic transactions coming out of your checking account. So there is another measure of a monetary supply aggregate known as M1. Okay, this includes the currency category, but it also expands that category to include checks and traveler's checks. Traveler's checks, of course, make up a relatively very small fraction of the money supply nowadays. Not a lot of people are utilizing those, but checking deposits, money in your debit account, that will show up in M1, but it does not show up if we just look at the amount of physical currency in circulation. There is another metric, and there are more, just like the unemployment rate, just like thinking about GDP and GNP, how to measure income or price levels, CPI, PPI, deflator. There are many different ways of trying to measure the money supply. And these are the three that are most widely reported. M2 expands the definition of M1 to also include savings deposits, small time deposits, and money market mutual funds against which you can write checks, arguably making those deposits extremely liquid. So the idea is if the assets are very liquid and you can spend them, whether or not it's currency or if it's something else, okay, then we would want to include that in the quantity of money when we're trying to measure the money supply. Just looking at these numbers, you'll notice the margin of error is huge. Okay, you compare the amount of currency to the amount of M2, the difference in order of magnitude is over tenfold. Okay, currency to M1, difference in magnitude is over twofold. So a big difficulty with asking the question, how much money is in circulation, is really how are you defining what money is? What's your threshold for how liquid something has to be in order for it to be considered a medium of exchange or a readily transactable resource? Now, the theory that we're going to start to get into today is known as the quantity theory of money. And the quantity theory of money explains the connection between money and prices, specifically money growth and price growth. So we're going to start here by revisiting the definition of the inflation rate, which is just the percentage growth in the level of the average price. Price itself is the amount of money required to buy a good, or equivalently, if we think of the price level, is the average amount of money required to buy a given bundle of goods. And since prices are defined in terms of money, we need to really consider the nature of money, the supply of money, and how it is controlled in order to understand better the behavior of prices. Now, the theory that we're about to investigate, this applies in the long run. We're actually going to use a completely different theory to think about the short run behavior of money and interest rates. And it's odd that the short run model as well gives us exactly the opposite prediction, but we'll get back to that later when we talk about liquidity preference. But the quantity theory is a simple theory that links the inflation rate to the growth rate of the money supply. We're going to take a look at a little bit of a supply and demand interpretation within the confines of this framework. And I think the easiest place to start is by discussing the concept of the velocity of money, okay, or the speed at which dollars are moving through the economy as they are transacted in purchases. So the velocity of money, okay, again, the basic concept is this is the rate at which money is circulating. And the definition is the number of times the average dollar bill changes hands in a given time period. Okay, and I think the easiest way to really think about this is just, let me give you a contextual example. Let's suppose that in a given period, the total amount of spending, if we added up all the nominal spending, was $500 billion. However, there was only $100 billion in circulation. Okay, so you're like, oh, how is that possible? Well, that means the dollars must have been spent more than one time. I spent them, person A spent them and gave them to person B, who turned around and spent them and gave them to person C. So $1 could be spent many times to account for a whole lot of money actually being spent, despite the fact there's only one in circulation. So in this case, we have $100 billion in circulation, but they were spent to account for $500 billion in total nominal transaction spending. So if you think about that, it's got to be the case that the average dollar then must have been spent about 5 times in order to account for the total $500 billion in nominal spending. So that implies that on average, the velocity of each dollar is 5. Each dollar was transacted 5 times to account for the total amount of spending. Okay, so based on our analysis, this suggests that velocity is defined in the following fashion. We would take the total nominal value of all transaction spending, which we call T, and we would divide that by the amount of money in circulation. So again, V is velocity, T is nominal spending on all transactions, and M is the quantity of money in circulation. Okay, now, if we think critically about T, the total nominal spending on all transactions, we know what that should be. That should be GDP, right? Nominal GDP specifically. So I'm going to go ahead and substitute the price level times real GDP, P times Y, that's nominal GDP up top. Okay, so again, P is the price of output, Y is the quantity of output, real GDP, and P times Y is the nominal value of that output, which again is nominal GDP. So this equation right here is the fundamental equation that is going to describe the relationship we are interested in momentarily. Okay? If we were to multiply, if we were to take this previous equation and multiply M through by both sides, and I'm going to put an S superscript to denote that this is the money supply, okay, then we arrive at the central equation of our theory, which is the quantity equation for money. Okay? M times V equals P times Y. This equation is an identity because it holds by definition of the variables. Okay? What we're going to do in a minute is we're going to look at some data about price growth and velocity. We're going to impose an assumption based off of that data for the U.S. economy. And then we'll be able to see a very close relationship between how M changes and how P changes. Okay, I want to talk for a minute about thinking about money demand for a moment. I know we were focusing on money supply, but consumers and firms, they demand money. And the amount of money people wish to hold, let's assume this takes a very simple form in that people just hold some constant fraction of their total amount of nominal income or their total amount of nominal spending as money. Okay, so if K is 1/2, then that says the average person holds about half of their spending in money, okay, or in cash if you want to think of it that way. Okay, that means the aggregate money demand is just equal to K times the total nominal spending. Okay, and what we're going to do in a minute is we're going to impose an equilibrium condition and look at what happens when the money supply equals the money demand. So recall our money demand function that we just looked at here is a very simple idea. People hold a constant fraction of their income as money. And the quantity equation, we could rearrange and solve for the money supply, just P times Y over V. And if we were to impose an equilibrium condition by setting money demand equal to money supply, okay, then we wind up with the following situation. And that situation is some terms cancel, right? The P's and the Y's on both sides of the equation cancel out. And then you multiply K over or V over one or the other. And we observe here that in equilibrium, the amount of money that people are holding as a fraction of their income, like your cash holdings, that is inversely related to the velocity, the speed at which the dollars travel. And this should make sense. Okay. So the simple model here, again, this implies an inverse relationship between money holdings and velocity. And the intuition here, why this makes sense, is the following. In order to account for a given level of spending, okay, so some amount of money was spent, $100 was spent. Okay, if there are fewer dollars in circulation, then those dollars need to be spent more to account for the total amount of spending that has occurred. So if consumers are holding less cash, then that means the velocity is going to go up because those dollars need to move faster to account for the same level of spending. And conversely, if there were more dollars in circulation, then again, to account for the same level of spending, each dollar would need to be transacted a relatively smaller number of times, okay, implying a lower velocity for a larger level of average money holdings. Now, if we look at the relationship between nominal GDP, P times Y, and the money supply, okay, you'll notice over time here, it looks like, for the most part, the growth rate in nominal GDP and the growth rate in the money supply is measured by M2 here are relatively constant. Okay, recall P times Y divided by M, right? That's nominal GDP divided by M2 here. that will give us velocity. And we can see from the data here that the velocity looks fairly constant over time. Okay. Velocity looks fairly constant over time. And we are going to use that assumption and impose that on our theoretical model. So let's jump back to the quantity theory of money. Before we do that, since velocity is not growing and we're going to think about things in terms of growth rates, let's just quickly recall how we could change this equation into its growth rate form. Okay. First and foremost, remember that if you have two variables multiplied together, A times B, and I want to look at the growth rate of the product of them, then the way that you would do that is you would just take the growth rate of each of the individual components and you would add them. So the growth rate of the quantity A times B is just the growth rate of A plus the growth rate of B. So if we were going to take our equation MV equals PY, M times V equals PY, and change that into growth rates, this would turn into the percent change in M, or the growth rate in M, plus the growth rate in V equals the growth rate in P plus the growth rate in Y. So this is the same equation, but just written in terms of the percentage changes. Now, we just observed in the data that velocity tends to be fairly stable over time. So we're going to go ahead and impose that feature on our model. And we could do that either in the growth rate form, or we could just go back to the regular equation, assume that V is some constant here. And then we could proceed accordingly. Now, you'll notice if V is constant, then if M increases on the left-hand side, that immediately means that nominal GDP increases on the right-hand side. Okay, so right now, we should be able to see that there's a very close relationship between the money growth and the level of nominal GDP, or nominal spending. Now, at this point, the model suggests the following. Okay, if V is constant, the money supply is determining nominal GDP. Now remember, real GDP, this is determined by the economy supplies of capital and labor and the level of technology in the long run. Okay, and again, P is the price level as measured by the GDP deflator. So what the quantity theory of money is suggesting here is the following. And before we discuss the implications, let's just redefine here one variable. I'm going to introduce the Greek letter pi and use that to denote the rate of inflation. I know in microeconomics, sometimes we would use pi to denote profit, but in macroeconomics, we use pi to denote the inflation rate. From the previous slide, assuming that velocity is 0, and we use the growth rate form of the quantity theory equation, what we can do now is instead of looking at the growth rate and prices, I could substitute in pi directly for the delta P over P terms, and then I can solve for pi. And when I do that, we get the following result, that the inflation rate is equal to the growth rate in the money supply minus the growth rate in output. So notice for a given level of the delta Y over Y term, if the growth rate in the money supply goes up, that will cause the inflation rate to go up by the same amount. So what we've shown here using this theory is that the theory predicts almost a one-for-one relationship between the growth rate in the money supply and the growth rate in prices. Now, what we have to be careful of here is how we really interpret this result. So first and foremost, if we have normal economic growth, this does require a certain amount of money supply growth to facilitate all these extra transactions that are happening in the growing economy. However, if the money supply growth, the percent change in M, is bigger than the percent change in Y, then growth in excess of this amount that's required to facilitate the new transactions, that is what is causing inflation here. So inflation is being caused by money growth in excess of the growth rate of output. Now, if we're in the long run and output isn't really changing that much, growth rate of output is 0 at its trend, then the theory predicts that a 2% growth rate in the money supply translates into exactly a 2% growth rate and prices are a 2% inflation rate. Now, there is an idea in macroeconomics known as the classical dichotomy, and the idea is that in the long run and short run, we treat variables a little bit differently, and how we treat these variables depends really on the type of variable. So we discussed the idea of real variables, which were measured in physical units, and quantities, and output. Okay, so this is like the quantity of output, your real wage, the real interest rate. These were all real variables. Not to be confused with nominal variables, which are measured in currency units. So your nominal wage is your dollars that you're getting paid. Nominal interest rate is measured in dollars. The price level is measured in dollars. And the classical dichotomy is an idea that suggests that real and nominal variables behave much differently in the short and long runs. So this is a theoretical separation between these types of variables, between real variables and nominal variables. And the idea suggests that in the long run, nominal variables do not affect real variables. Okay, so anything measured in dollars, like the price level, when we change that in the long run, that's not going to affect anything like the real value of output. Okay, what that implies is that in the long run, trying to grow the money supply will not actually change the level of output. Okay, rather, it's just going to push prices up, but it is not going to affect the level of output, which is a real variable. Okay, and when we look at the data, we do see that in the long run, money is approximately neutral, meaning in the long run, if growing the money supply isn't affecting the level of output, then that must be translating into inflation as the theory predicts. So again, if delta y over y, if that term is zero, okay, because changing m in the long run would not affect y, okay, then this theory predicts literally a one-for-one relationship between changes in the monetary growth rate and changes in the inflation rate. Okay, so if this theory is true, we should be able to look at a lot of different countries, look at their growth rates and their money supplies, and then observe a positive relationship when I compare the growth rate and the money supply to the inflation rate. So let's go ahead and do that. Okay. The theory should imply the following. Countries with higher money growth rates should have higher inflation rates, as well as the following. The long-run trending behavior of a country's inflation rate should look similar to the long-run trending behavior of the country's monetary growth rate. So the question is, are the data consistent with these implications? And the answer is, unfortunately, it really depends on how far back you are looking in the data. Remember, this is a long-run theory. So if you look carefully at this caption here, I'm going to use a decade, a 10-year period here. Okay, and I'm going to plot on the horizontal axis the average monetary growth rate, and on the vertical axis, the average inflation rate for many different countries. And you'll notice here, averaged over the decade period, there is an extremely tight positive relationship between the growth rate and the money supply and the average inflation rate over this 10-year interval. Okay, we could also look by decade, averaging across countries. And again, provided we're looking over a long enough period, we still see here, averaging within decades across countries, a very strong positive relationship between the average money growth rate and the inflation rate. So this is great support here for the quantity theory that we have developed. Okay, it looks like the data is saying that what the theory predicts is correct. However, if we were to use bad data, meaning if I just looked at every year within a decade, okay, then you'll notice that relationship breaks down and there is not a strong positive relationship anymore between money growth and the inflation rate because we're using the wrong time horizon. Okay, this is a long-run theory, not a short-run theory. It applies in the long run, not in the short run. Okay, if you look at this data, it's kind of hard here to discern really what's going on. Okay, that growth rate of M2 is kind of all over the place. So is the inflation rate. And again, Here we're kind of looking at a short run analysis year by year. We're looking over a very long time span, but each of these data points is really close together. However, remember what the theory predicts. It predicts that the inflation rate in that red series and the monetary growth rate in that green series, they should share the same long run trend. Okay, so if we fit, or rather filter, the long run trends of both of those data series, we do observe this quite nicely. The long run trending behavior of the monetary growth rate and the long run trending behavior of the inflation rate, they do behave similar, which again is a prediction of this model. Now, the next component that we're going to utilize is something known as the Fisher effect. And in order to discuss this, we need to discuss the difference between the nominal interest rate, which is not adjusted for inflation, and the real interest rate, which takes the nominal interest rate, it subtracts out inflation, implying that we could define the nominal interest rate as just the real interest rate plus inflation. Okay, so the nominal interest rate, this is the interest rate that measures the dollar return for a dollar invested. And the Fisher effect is just the equation that describes the relationship between the nominal interest rate, the real interest rate, and inflation. Now, remember where the real interest rate is determined. That's determined in that market for loanable funds. So given a level of the real interest rate, an increase in the inflation rate is going to cause an equal increase in the nominal interest rate. And this one-for-one relationship between the inflation rate and the nominal interest rate is known as the Fisher effect. Okay, so if you were to look at data of the nominal interest rate and the inflation rate over time, the Fisher effect suggests that those two series or those two variables should move fairly closely together, and they do. Okay, there are some periods where they don't, they move separate from each other, but that's because R changes, the real rate of return changes as the activity in the loanable funds model exhibits dynamics. And here's another picture of a cross-country comparison where, again, we have the inflation rate on the horizontal axis here, the nominal interest rate on the vertical axis, and you can see there is a strong positive relationship between those two things. So, to conclude and to summarize, the quantity theory predicted a positive relationship between the growth rate of the money supply and the growth rate of inflation. Okay, increasing the money supply, increase the inflation rate in the long run, decreasing the money supply, decrease the inflation rate in the long run. The Fisher effect, also which had a significant amount of statistical evidence supporting the theory, suggested that an increase in the inflation rate for a given level of R, the real interest rate, an increase in the inflation rate would increase the nominal interest rate as well in a one-for-one fashion. Conversely, it predicts a decrease in the inflation rate will push the nominal interest rate in the downward direction. Okay, if we put both of these mechanisms together, the quantity theory and then the Fisher effect on top, together they imply the following long-run relationship between money growth, inflation, and nominal interest rates. That growing the money supply pushes prices up, and that increased inflation then translates into higher long-run interest rates. So this is our first time here putting a link together between money supply growth and nominal interest rates. We've done this for the long run. We're going to think about this in a little bit in the short run in some videos to come. An odd thing to keep in mind is that in the short run, we're going to wind up making the opposite prediction. Okay, that there's actually an inverse relationship between the money supply and nominal interest rates. So keep an eye out for those videos to come, and we will see you then.